Hello, today we're going to be working with adding and subtracting positive and negative mixed numbers with like denominators. This can be tricky. I know here's what everybody wants to do, and I'll just show you. Everybody wants to go 7 minus 3 and say that that is 4, and then they want to go 10 minus 7 and say that that is 3/13. Well, unfortunately, that doesn't work. It would be super easy if it did. But the problem is those arrows have to go the same way. So when you find the difference, you need to subtract 7 minus 3, and you need to take this fraction minus that fraction. We didn't do that. So there's two different ways we can do that. Here's the first way. Improper fractions always work. I'm going to repeat myself. Improper fractions always work. 3 times 13 is 39 plus 10, make this 49/13. Plus a negative, 7 times 13 is 91. 91 plus 7 is 98/13. Now you can find the difference. 98 minus 49 is equal to 49/13, which, as you remember, is going to be 3 and 10/13. Right up here, we have that same thing. But if you're not sure, you can just take and do 49 divided by 13. Here's your 3 times. Here's your 39. There's your 10 left over. 3 and 10/13. Now you have to determine, is that positive or negative? Well, the negative has a larger absolute value, so this is a negative. So that's the first way you can do it. It always works. A little more work, but it always works. You can also think about it this way. 3 and 10/13. And we're going to add a negative 7 and 7/13. Well, we can start right off the bat. Let's grab a different pen here. We just go right off the bat and say, hey, I can do 7 minus 13. That's great. Or 7 minus 3. I can find that. But I can't do this. So I can rewrite this. I can make a trade. I can call this negative 6, and I can take 13/13, which is one whole, because here I subtracted one whole, right? There it is, there's 13/13, and I can add it to the top, so I can really call this 6 and 20/13. So I've renamed that. Let me slide this up. So I've renamed it 6 and 20/13. And now 3 and 10/13 minus or plus a negative 6 and 20/13. Well, now I can go both ways. 6 minus 3 is 3 wholes. 20 minus 10 is 10/13. This has the greater absolute value. So once again, we get negative 3 and 10/13. So if you understand this trade here, you can use that method. I'm going to go through both one more time again. Actually, on this next problem, we don't need to worry about it, because now we're doing addition. Addition is friendly. We are adding these two terms, which are both negative, so we're going to have just a bigger negative number. So when you add, again, you could take and put these into improper fractions like I showed you in the video, and it always works. When in doubt, just put them in improper fractions. But we can cheat here, and we can say that this is negative 7 because we added them together. And 3 plus 4 is 7/13. Okay? We could Sal Khan this one. He would say this is negative 5 plus a negative 3/13 plus a negative 2 plus a negative 4/13. That's the way Khan looks at it. And you can see how when you add those together, you have -7 and a negative and 7/13. And the whole thing is negative. You don't need to put that second negative somewhere. All right? All right. Let's look at 2b. Now, I'd like you to resist the urge to just start adding and subtracting these things. You have to think about what you're doing here. You can take the 4 minus the 1, and you can take the 9 minus the 1, but again, you're going in two different directions, and that doesn't work. You have two different signs here. You've got a positive and a negative. So you have to find the difference. This is really a subtraction problem. I'm going to do this both ways again on this one for you here, just so you understand. First of all, improper fractions always work. So that's what I'm going to do first. -1, so 1 times 11 is 11, plus 4 would make this 15 11ths, and that's a -15 11ths. We're adding 9 times 11 is 99, plus 1 is 100 11ths. Now, doesn't that look simple? Positive, negative, the difference is 85 11ths, and it's positive because this one here has the greater absolute value. You just slide up, and let's see, what is 85 11ths? Well, divide it out. 85 divided by 11 goes into 7 times, it would be 77. 15 minus 7 has got 8 left over, so it's 7 and 8 11ths. 7 and 8 11ths. It's positive 7 and 8 11ths. Okay, let me do it the other way with a trade. Okay, so we are going to rename this one. I can take 9 minus 1, but I can't go 1 minus 4. So I'm going to rename this. I'm going to call this one 8, and I'm going to add 11 pieces to this top. So that's 11 plus the 1 gives me 12. So I've renamed this. Let me write the whole thing on 1 and 4 11ths plus 8 and 12 11ths. Now I can subtract. 8 minus 1 is 7. 12 minus 4 is 8 11ths. You'll notice we got the exact same answer. Yes, it's positive because this has the greater absolute value. So think about that. You have to use one of those two strategies. I know a number of you will probably just try to do it in your head, and I'm just begging you. You're going to get the answers wrong. It takes a little bit of work. So please work hard on this one. Good luck.